So the Lewis definition, and in your worksheet it was asking you to compare different definitions of acids. So what do you think of when you hear the name Lewis in terms of chemistry? Lewis dot structures, right? And what features prominently in those? Electrons. So the Lewis definition of an acid is focusing on electrons. The acceptance or the donation of an electron pair. The Bronsted-Lowry model focuses on the proton. Are we accepting or donating a proton? The Lewis model focuses on the electron pair. So this is a base, ammonia. It has a lone pair of electrons. It can donate those electrons to the hydrogen ion and form a bond. So the hydrogen ion is acting as a Lewis acid because it's accepting the electrons. The ammonia is acting as a Lewis base because it's donating the electron pair. What I find confusing about this is the Bronsted-Lowry definition was the acid donating and the base accepting, right? And this is the opposite. So I prefer to think of the Bronsted-Lowry acid definition and then figure out this based on that. And what I mean by that is, so here, where's my stupid pointer? Come on. Well, that thing I'm trying to point at, the H+. There is a logical explanation for this technological no man's land I'm in, but it's not worth the time to figure it out. So the hydrogen ion is positive and electrons are negative. And so what we're looking at is the same transaction, but from a different point of view. So looking at accepting the proton, so the NH3 is accepting the proton. In the process of doing that, it's donating these electrons, it's sharing this pair of electrons with the hydrogen ion. This is not a huge deal, so if you're just like still stuck on something else, you can skip this. It won't be the end of the world. Why do we even talk about this? Because the Lewis definition expands the substances that can be considered acids. In the Lewis definition, an acid doesn't even have to contain hydrogen. So here we have BF3 and NH3, and so we've got this lone pair here. The boron here has an incomplete octet. It only has 6 valence electrons in its Lewis structure, and so it is pretty happy to connect up with this NH3 with its lone pair here, and it forms this thing, right? So that's called an adduct. They're like just kind of stuck together. So Lewis acids are going to accept electron pairs. So the Lewis acid has to have an empty orbital or is able to rearrange its electrons to form an empty orbital that can accept that electron pair. The hydrogen ion has an empty orbital, right? Because it has no electrons. It definitely has an empty orbital that it can accept the electron pair from nitrogen. So these are some molecules that act as Lewis acids. So here we have aluminum chloride, and this can act as a Lewis acid by forming this adduct with ammonia. Now that's a different way of the aluminum ion acting as an acid than we looked at before with it making the complex ion. Here we've got boron trichloride, and here we've got, this is an ether, and the oxygen in the middle here has 2 lone pairs of electrons. It can donate one of these lone pairs to this boron that has an incomplete octet, and so in that way this acts as a base and that acts as an acid. this whole business is important for organic chemistry. Some molecules don't have empty orbitals, but they can rearrange them so that it works out that way. So here we have water, which can act as a Lewis base, and here's carbon dioxide. So carbon dioxide, the carbon has 2 double bonds with oxygens, and it doesn't have an empty orbital. But the second pair of electrons can go up here, come on, up there, onto this oxygen. This pair of electrons can then be shared with the carbon, and this hydrogen, well, let's go over here now. So we've made this bond by moving electrons up here and moving a lone pair from the oxygen over here. And then the lone pair here can act as a base with the hydrogen by donating its electrons to the hydrogen. And these electrons then come down onto the oxygen. And so that's how carbonic acid is formed between water and carbon dioxide. I'm not even going to ask you if you understood that, because I don't really expect you to understand that. I actually would have a hard time drawing this out from nothing myself. But a lot of students ask me, well, what's organic chemistry like? Well, there's a lot of this drawing of arrows and moving of electrons around. That's a big deal in OChem. So here we've got cations. We talked about these before, but now we're going to look at how they act as Lewis acids. So aluminum ion, and here water is acting as a Lewis base, and so the water is going to donate electrons to the aluminum and form this complex ion. The aluminum has empty orbitals because it's lost its valence electrons.